math analysis. I am going to explain pages 25 and 26 to you. So first off, you're not going to be able to see the calculator. I've tried to pull that up. I apologize. So I'll just have to talk you through it. So we have an incentive at the Lane Elementary School. Let's hear a shout out from any of you who went there. Woohoo! And they are giving away silly bands for minutes for reading. So Miss Parada has 43 silly bands, and Megan read 230 minutes, Erin 312, and Caitlin 200. We're going to use the Hamilton method to determine how to distribute the 43 silly bands or apportion them. So first off, remember to find the ideal ratio. It's the total population, which in this case is the number of minutes read, divided by the number of objects. So I would add together the 230, the 312, the 200, hit total, and divide by 43. And that gives us an ideal ratio of 17.26. So for the meaning of what that ideal ratio is, think about what we did. It was the total number of people per object, or the total number of minutes. So for every 17.26 minutes of reading, you earn a silly band. All right, the next step in the process is to determine the quota. So remember, you take each individual class size, which in this case would be the number of minutes that each student read, and divide them by the ideal ratio. And it gives us the exact amount of silly bands that the students deserve, but we know that's silly because we would never cut a silly band up. But this would total up to exactly 43. So the quota describes the number of silly bands each student deserves. All right, for the Hamilton method, remember what he does is to find the initial apportionment, he truncates the decimal, so he distributes the integer amount. That adds up to 42. He needs to give one more away. So we look here at the largest decimal, and he gives it to the guy over here, Caitlin. She gets the extra one. All right, next they asked us to do this method again, this time with 5 silly bands. And there are a total of 3 children. These are the number of minutes that they read. So if you total them up and divide by the 5 silly bands, the ideal ratio is 36. So for every 36 minutes of reading the students do, they receive 1 silly band. So we take the number of minutes read divided by 36, each guy here, and this gives us their quotas. Jefferson also truncates the decimal part, so he awards 2 to Connor, 1 to Rachel, and none to David. Now, this is a little bit harder. Jefferson has to calculate the adjusted ratio. So he takes each individual kid, the 92, and divides by 1 more than they were given initially. So 92 divided by 3 gives us Jefferson adjusted ratio of 30.67. 57 divided by 1 more than he got, so 2, 28.5, and 31 divided by 1. We got to give 2 away. We're comparing to the ideal ratio. So the first one who's going to get the extra silly band is David by the Jefferson method, and the second one will be Connor because they are the closest to the ideal ratio of 36. All right, and finally, we got rid of the Jefferson method because it favors the larger classes in lieu of the Webster method. So the Webster method does a couple things differently. It doesn't start until the quota. So he once again figures out the ideal ratio the same way. He adds up the minutes and divides by however many silly bands there are. So the ideal ratio is 5.23. Add up these minutes divided by the 30 starbursts, no silly bands this time, and divides each kid's minutes read by the ideal ratio, giving us the quotas. Instead of truncating, however, Webster rounds. And so here we go. He's rounded all these quotas, and you can tell that he is giving away, rounding up each one, so he's giving away too many. So he has to take 1 back. That means he's going to use the formula that has the negative in it with the 0.5. So the individual minutes read by Jake was 41. Initially, he gave him 8 starbursts. He's going to divide by 7.5. 55 divided by 10.5 and 61 divided by 11.5. The one that's closest to the ideal ratio turns out to be Tori, so she's the one who will lose the starburst, and now we have our total of 30.